So let's take a look at these problems that require the special integration formulas. So if we do number 20, the square root of 5x squared minus 1. So the integral of the square root of 5x squared minus 1 dx. So first we need to identify our u and our a. Very important, because we have to first bring out our du, or if we have some kind of constant, we have to bring that out in front of the formula that we use. So what's our u? Square root of 5 times x, right? Because this is 5x squared. If this is u squared and you take the square root of it, you get the square root of 5 times x. So our du is equal to the square root of 5. So we're going to need to bring out a 1 over the square root of 5 before we do anything with our formula. Okay? Then a is going to be what? Just 1, because that's a squared. Alright, so let's look back at our formula real quick. So we have the square root of u squared minus a squared. That's what we're going to follow. Now, I told you we need to bring out our du though, so I might have to bring a 1 over the square root of 5 out in front of this 1/2. So 1 over the square root of 5 times 1/2 times, now I just start following my formula. So u times the square root of u squared minus a squared. So u is the square root of 5 times x times the square root of u squared minus a squared is square root of 5x squared minus 1 minus a squared natural log of absolute value of u, so minus a squared, a is 1, so minus 1 squared natural log absolute value of u, right here, plus the square root of u squared minus a squared plus c. So plus the square root of 5x squared minus 1 plus c. So now I can multiply in this to that term and this to that term. So that's going to be, the square root of 5's cancel out when you multiply that in there, and just leave you with 1/2 x square roots of 5x squared minus 1, and that's going to be minus 1 over 2 square roots of 5 natural log absolute value square root of 5 times x plus the square root of 5x squared minus 1 plus c. You can rationalize this too. So if you multiply the top and bottom by the square root of 5, then that's going to be what in the denominator? 10. And you'd have a square root of 5 in the numerator. Alright. So that's how you follow the formula. You find the u, you find the a, you find your du, adjust for the du, and then just follow the formula. Okay. The next section, notice it doesn't tell you which method to use. So, you know, when I give you a test on this, I may say use this method, or I may just say, hey, have at it. Integrate this. Okay? So I'm just going to randomly pick one of these. Let's say that we choose, I want to choose an even one, that way, because you can always get all of the solutions and answers for the odd problems. 26 looks as good as any. So the square root of 25x squared plus 4 over x to the fourth. Alright, so first we need to recognize what form this is in. So I see a square root of u squared plus a squared. So that's going to be what type of substitution? Tangent. So that's going to be a u equals a tangent theta substitution. So what is our u here? That's very important because it's not just x. It's 5x. So 5x equals, what is our a? 2 tangent theta. Now before we can find our dx, we have to solve for x here. So you just divide both sides by 5 and you'll have x equals 2/5 tangent theta. That's the substitution that we want to make anyway. Okay? And so dx equals 2/5 secant squared theta d theta. So now for every x, I'm going to plug in a 2/5 tangent theta. And for the dx, I'm going to plug in a 2/5 secant squared theta. Alright, so right here, I'm going to plug in a 2/5 tangent theta, and I'm going to square it. The dx is 2/5 secant squared theta d theta over, that's going to be 2/5 tangent theta raised to the 4th power. So I'm going to need to square the fraction in front and square the trig function. I'm going to need to square this fraction in front and square the trig function. Let's see what happens when you square 2/5 and multiply it times 25. That's going to be 4 25ths. When you multiply 4 25ths times 25, what do you get? 4. What's the trig function going to be? Tangent squared theta. And then I have what here? Plus 4. It's kind of funny how that works out, huh? Because now I can factor a 4 out of those two terms and use my Pythagorean identity. Well, it works out that way because of the formula that we use to set this problem up. It has to work out that way. So if you start getting in this part of the problem and you don't have a constant you can factor out and give you some type of Pythagorean identity, then you messed up. That's kind of an indicator that you need to go back and see what you did with your fractions or your numbers or something like that. Now, 2/5 raised to the 4th power, and it's in the denominator. So if I bring it out, I have to flip it and multiply. 2/5 raised to the 4th power is going to be, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, over 5 times 5 is 25, times 5 is 125, times 5 is 625. Now, does everybody see that I have 4 of those in the denominator and I have 1 of those in the numerator? That way I could cancel one of those out, and instead of bringing out a 625 over 16, I can bring out a 125 over 8, because the 2/5 on the top is going to cancel some of those out, just one of those out. So it's 125 over 8 on the outside. Hopefully I didn't do too much there. Oh, that's to the fourth on the bottom. So I brought out this, but before I did, I canceled one of these out. So I'm bringing out 2/5 times 2/5 times 2/5 in the denominator, which when you flip and multiply is 125/8. All right. Now, what's under this radical you can factor a 4 out of, and you'll have 4 times tangent squared theta plus 1. Now, what is tangent squared theta plus 1? What is that? Secant squared theta. All right, so actually under the radical, I have 4 secant squared theta. And you can take the square root of that, right? The square root of 4 secant squared theta is 2 secant theta. So I have 2 secant theta. That's what comes out of all of this. Then times secant squared theta over tangent to the 4 theta d theta. All right, so I can bring in a 2 out, it looks like. And so I'll just put the 2 in front here. It's going to be secant cubed theta over tangent to the 4th theta d theta. Usually what I do if I have secant and tangent and it's a quotient like that, I like to change everything to sine and cosine because I'm more comfortable working with sine and cosine. And that may not be the right thing to do here. It's just something that I'm going to try. I mean, but if there's some way you can think about integrating where you have a u and a du, I really don't see it. I can't bring a secant squared out and change the other secant over. That's not going to work. I can't change the other secant. I just have a secant to the first left, and I can't change that to tangent. So I'm going to change everything to sine and cosine. So I have 250/8 times the integral of secant is going to be 1 over cosine. So that would be 1 over cosine cubed theta. Now, if you bring tangent to the numerator, it becomes cotangent. And cotangent is cosine over sine. And both of those will be to the 4th. Alright, so all I did is I brought tangent to the top and made it cotangent to the 4th. And then cotangent is cosine over sine. So all of these and all but one of those will cancel out. So I have 250/8 times the integral of cosine of theta over sine to the 4th theta d theta. So now this becomes a pretty easy integral. Does anybody see it? This one here?
Yes, sir.
Whenever you bring this up, it becomes cosine to the 4th over sine to the 4th. Do you understand that? Because when you bring the tangent up, it becomes cotangent to the 4th. And cotangent to the 4th is cosine to the 4th over sine to the 4th. And so that's what that was. Secant to the 3rd is the same as 1 over cosine to the 3rd. And so those 3 of those cancel 3 of those out and leave you with 1 of those. Okay. So now the integral is easy. Come on, y'all can do this. Yeah, it's just a u substitution. Let u equal sine of theta, then what is du equal to? Cosine of theta, and look, cosine of theta is present right there. So you have the du present, so this is going to be 250 over 8 times the integral of, how can I rewrite this now? 1 over u to the 4th du. Alright, so we're integrating u to the negative 4. So that's going to be, if that's u to the negative 4, add 1 to the power to be u to the negative 3 divided by negative 3. Alright, so that's going to be 250, and this is all going to be negative 250 over 24 u to the 3rd plus c. And so I just need to plug in for my u now. What was my u? Sine. So this is going to be negative 250 over 24 times sine cubed theta plus c. Now, we don't want to leave our answer like that. That's not a good way to leave your answer, because we started out with algebra. Let's see, right here. And we want to end with algebra. So come up here where you had 5x equals 2 tangent theta. That was the substitution we used. 5x equals 2 tangent theta. And get the tangent theta by itself so that you can make a right triangle. And we can define theta according to whatever this is, 5x over 2. So tangent is opposite over adjacent. So that's 5x, that's 2. What's this going to be? Square root of 25x squared. Is it plus or minus? Plus. Alright, plus. Plus 4. Alright. So, it might have been good for me it may be good for me to move this sign to the top and make it cosecant, but I'll worry with that in just a second. The reason I say that is because sine of theta here, sine is opposite over hypotenuse. Sine of theta is 5x over the square root of 25x squared plus 4. So that would make cosecant equal to the square root of 25x squared plus 4 over 5x. And so if I rewrote my answer, remember, moving trig functions is not the same as moving variables. When you move a trig function, it just becomes its reciprocal. So I have negative 250 over 24 cosecant cubed theta plus c. Alright, so if I plug that in and cube it, negative 250 over 24 times the square root of 25x squared plus 4 over 5x cubed plus c. You probably don't want to cube out the top. I probably just want to write it as the what power. What power would that give me in the numerator? Yeah, 3/2, right? Because that's 1/2 and that's 3. So you could write that to the 3/2 power. Very good. And then if I cube the bottom, that's going to be what? 125x cubed. And so you can cancel this and this out and get a 2 right there. So I have negative 2 over 24 times, and it doesn't really matter. I mean, you can leave this constant out front and then you could have 25x squared plus 4 to the 3/2 over x to the third plus c. Okay. Alright. Let's see what would happen on a problem like this. If we try to apply the same property, the same trig substitution property. So we'd want to think about this like it was u squared plus a squared. So it'd be a similar substitution as before. We would have u equals a tangent theta, or 4x equals what? 1 tangent theta. So x equals 1/4 tangent theta. So dx equals 1/4 secant squared theta d theta. So if I plug in for x 1/4 tangent here, and I plug in for dx secant squared here, 1/4 secant squared. I wrote 2 dx's, I'm sorry. I'm double dx today. Alright, so that's going to be over, when I plug that in for x and square it, I'm going to have 16 times 1/16 tangent squared theta plus 1. And all of that is squared. Right? This squares on the outside. And actually, I'm plugging it in right here, so it's tangent squared, and then the plus 1 is right here. So the 16s cancel out. That's very convenient. Well, that's part of the reason why we set the problem up the way we do, so that that will happen. I'm going to write the 1/4 in front. And what will I have left in my parentheses now? Okay. I'll have, see, because that cancels out, and I'll have tangent squared plus 1 squared. And what is tangent squared plus 1? Secant squared. But that is squared. So I'm going to have 1/4 times the integral of secant squared theta over secant to the 4th theta. Right? So that's going to be 1/4 integral of 1 over secant squared theta. We can't do that integral, can we? So what will we have to do? Rewrite this as 1/4 times the integral of what? Cosine squared. Oh, that looks better. Because now I can use the power reducing formula. And the power reducing formula for cosine is 1/2 times 1 plus cosine 2 theta. I can bring that 1/2 out, and now I have 1/8 times the integral of 1 plus cosine 2 theta, d theta. So that's 1/8 times, what's the integral of 1? Theta. What's the integral of cosine 2 theta? Not the derivative, the integral. 1/2 sine 2 theta plus c. Alright, so I have 1/8 theta plus 1/16 sine 2 theta plus c. Now, I don't want to leave my answer like this. So, I have to make my right triangle. What was the substitution that I used? X equal, or 4x equals 1 tangent theta. So 4x equals 1 tangent theta, or tangent theta equals 4x over 1. So that's 4x, that's 1. That means that this has to be the square root of 16x squared plus 1. Now, with the theta, whatever type of substitution you use here, use that inverse function. So this is going to be 1/8 inverse tangent of, you don't have to put 4x over 1, you can just put 4x. Uh-oh. How do we make a substitution in right there? We can't, because there's no formula for 2 theta just directly. But for sine of 2 theta, we can substitute in 2 sine theta cosine theta, because that's a trig identity. Alright, so that's going to be 2, what's sine of theta? Opposite over hypotenuse. So 2 times 4x over the square root of 16x squared plus 1 times, what's cosine? Adjacent over hypotenuse plus c. Alright, so that's 1/8 inverse tangent 4x. Now I have a 4, a 2, a x. So that's going to be 8x over 16. So that's going to be what? Plus x over 2. Right? Because the 8 and the 16 cancel out. Now what happens when I say this square root times this square root? It's just going to be 16x squared plus 1 plus c. That's my answer. I'm done.